Okay, today the paper we are discussing will be the paper from Ananda College, and this is their final paper. They have put final term test, so I think they have covered their syllabus and everything. October 22, one of the most recent papers, right? First of all, let me how's the audibility of my sound, and I hope you can see the screen. Please give me a quick confirmation. Hurry up. Hello. Right. Okay. Thank you. So let's get started without delaying. So first question, it is about units and dimensions, I guess. Units and dimensions. Right. First 4 questions. Let's quickly analyze. What is the physical quantity which has unit kilogram second minus 2? Kilogram second minus 2, it is fundamental SI unit. Tension is a force, so it has kilogram ms minus 2. That can't be the answer. Energy is kilogram meter squared second minus 2. That can't be the answer. Power kilogram meter squared second minus 3. That also can't be the answer. Heat conductivity is people. Heat conductivity definitely can't be the answer because it will have now it is watt per meter per Kelvin, watt per meter per Kelvin, isn't it? Watt per meter per Kelvin, that is equal to kilogram meter squared second minus 3 into meter minus 1 Kelvin minus. So Kelvin also will be there in the final answer, and we are getting something like this: kilogram meter second minus 3 Kelvin minus 1. So obviously it can't be the answer, but I'm just showing you surface tension is definitely the answer, because surface tension is equal to force acting per unit length, force over length. That means it is kilogram meter second minus 2 divided by meter, and final answer kilogram second minus 2. Right. So third, the circular scale of spherometer with 1 millimeter pitch is divided into 100 parts. The magnitude of the measurement shown in the figure is. Now they should have indicated which one is 0. Since the answers are 1, 2 and all, let's take this as 0. This is 1, this is 2, this is 3. Okay. So people, definitely the answer is between 2 and 3. The answer is between 2 and 3, which makes first one, fourth one and fifth one incorrect. So it's either second or third. And the other point is, you can see the spherometer, it has, the disc spherometer has gone below the main scale 0, and 35th unit is coinciding. That means it has not actually moved 35 units downwards. What is the meaning of that one? 100 minus 35 equal to 65 divisions moved down. 65 divisions moved downwards. That is how you take the reading of spherometer. Moved downwards. When you when the spherometer disc is below main scale 0, you can't take that number directly. You have to subtract it from the total number of circular scale divisions and only get the unit. So reading is going to be equal to it is between 2 and 3, so it has gone past 2, so it's 2 plus 65 into 0.01 millimeter. So final answer is 2.65 millimeter. All right. So the answer is second one. Second one. Good. Right. Third one. Radio wave, microwaves, gamma waves, X-rays. According to the above type of wave, which has the maximum and minimum wavelength respectively? Maximum, minimum wavelength. Okay, people. So we all know when you compare frequency, wavelength. We directed at wavelength. No? Wavelength. Out of these, we'll quickly arrange them according to wavelength. Radio wave has the highest. Radio wave has the highest wavelength, and then microwave, and then X-rays, no? X-rays, and finally gamma. So radio waves, maximum radio waves, that is A is maximum, and gamma is minimum, C is minimum. A and C is the answer. A and C is the answer. Is there an answer like that? Yeah, first one. Okay, so I'll quickly go through these questions. If there's any problem, please stop me. Yeah. When a ball is projected downwards, it will collide against the ground at 20 meter below and rebound to the same height. If 50% of energy is lost in the collision, the projecting velocity will be. That's an interesting question. Now this is what they're saying, people. That is the ground, okay, and the object is thrown vertically downwards at a certain initial velocity from a height of 20 meters, I believe, right? And it's going to hit the ground at a certain velocity. We'll take that velocity as v1, right? v1, and it is not rebounding at the same velocity, v2, and it reaches the same height, but final velocity will be what then? 0. This is once again 20 meters. 20 meters. All right. So earlier you have higher energy. Here you have high energy. You have put. Okay, sorry people, there was a power cut. Okay, apologies. Can you hear me? Okay, thank you. Right, can you see the screen? That's right. Okay, thank you. So let's move on. The question. So I was explaining this question, the fourth one. The object starts at certain speed at a height of 20 meters. So what I'm trying to say is that has initially that has kinetic energy as well as potential energy. But once it hits the ground and rebounds, its kinetic energy is lost and it reaches the initial point, but it will be at 0 velocity when it reaches there. If 50% of energy is lost in the collision, the projecting velocity will be. So they are asking what is u. Okay, so what's the plan here, people? What's the plan? 50% of energy is lost. That means when you compare between these two energies, you can say half m v2 squared is equal to 50%. That means 50% of half m v1 squared. Good. That's the idea behind that. 50% energy is lost. So the entire this kinetic energy is not equal to this, half of this. So with this idea, let's see if we can approach the question. So what are the equations I can be writing here? I can say, all right, few equations one by one. So we will take this as point A to point B. Point A, this as point B. Okay. So first of all, from A to B, if I apply energy, conservation of energy, here we have half mu squared plus the potential energy, that is mgh equal to half m v1 squared. But write first equation, and then the object is bouncing back from B and reaching A once again. So they are from B to A. From B to A, it is going to be half m v2 squared, equal to mgh. Half m v2 squared is equal to mgh. I hope that's clear to everyone. Good. Half m v2 squared is equal to mgh. Yes, half m v2 squared is equal to mgh. instead of half mv2 squared, what can I put? I can put this value, that is instead of half mv squared I can put half mv1 square. Okay, sorry, half into half mv1 squared, no, half into half mv1 squared equal to mgh, and then that means half mv1 squared is equal to 2 mgh. I hope you guys understood it. From here to here I have written the energy conservation, then I'm writing the energy conservation from here to here, and I know a relationship between half mv1 squared and half mv2 squared. They are saying there's a 50% energy loss. That's why I wrote it this way. Then I have an equation of half mv1 squared. I don't want that these velocities v1 and v2. Then if I plug this into the first equation, what's going to happen? For the first equation, the first equation will give me something like this. On the left hand side nothing changes, half mu squared plus mgh. On the left side nothing changes. On the right side, instead of half mv1 squared you can put 2 mgh. So this mgh and mgh get cancelled out. I have half mu squared equals to mgh, right? So answer, this m and this m gets cancelled out as usual. U squared is equal to 2gh, and u is equal to square root of 2gh, square root of 2 into 10 into height is 20, that is u is equal to square root of 400. I'm getting 20 meters per second. Anyone else who got this answer? 20 meters per second, and that is the second one. Right, people? Yeah, should not be a huge problem. Quite manageable, isn't it? Second one. Right. So that's the end of first 4 questions. Let's quickly move on to the next part, people. So next we have to move on to question number 5. That I have to go back to the PDF. Right. I hope you can see question number 5. And yeah, question number 5. Here we go. A piece of ice was immersed in oil which float on water, as shown in the figure. Shown in figure. By connecting a metal sphere to the other end of the string, which connected to the piece of ice. After the piece of ice was completely melted, what can happen from the following? So a piece of ice was immersed in oil which flows. Okay, so this is the piece of ice initially, no people? This is a piece of ice initially. So now it's going to melt completely. Once it melts, ice will become water. Correct, people? Ice will become water. Ice will become water, yeah. And that water will go down. Right? And water level will go up. Oil level, what is going to happen to the oil level? That's what we have to consider. I'm not very happy with this diagram. So I'll redraw the diagram, only the cross-sectional area. That will be easier for us. So let's put it like this. Right, oil and water. Oil was floating on what initially? Remember, they have connected a heavy object to a string, is it? Metal. Okay, metal will submerge anyways. This is ice. Initially we have a piece of ice connected to a piece of metal. Metal is heavy, but because of ice it floats. Now this is water, this is oil, and this is ice, and this is metal. Okay, when ice melts, what will happen? Once ice melts, what happens is, okay people, volume of ice and volume of water, what can you say about them? Once now these marks I'll just use as reference. We need that to, we need that as a reference, people. When ice melts, okay, so say you have ice and let's say it melts and becomes water. whose volume will be larger. Let's say volume of ice is V1, volume of water is V2. Which volume is larger, V1 or V2 people? V1 will be larger. V1 will be larger. We know ice has a ice will be occupying a larger volume than water. Okay, right. So once ice has melted, there will be no one to hold the metal. Metal will go down. Metal will go down, and the string will just fall down like this. String will fall down like this. Metal will go down. Then there's going to be no change in water due to metal sinking. But ice will be melting. Ice will be melting. Because of that, that molten ice will turn into water. So definitely, water level is going to increase slightly. Water level will increase slightly like this. And so by what volume will water level increase? This one will increase by V. It will increase by what volume, people? Was oil? Sorry, not oil. Ice has molten and turns into water. So it will not be V1. It will be V2. V2. No, V2. Now this is water. More water is added to that. So the increment in this volume is V2. Increment in this volume is V2. Remember, V2, because ice melts and become V2 water, V2 volume of water, and that water will go below ice because water is denser than, sorry, that volume will go below oil, that is denser than oil, so it will go below oil. V2 has gone up. And what will happen to the oil level? Will it go down or up? That's what we have to decide. So this space of oil was occupied by ice, which has a volume of V1. It was occupying a volume of V1. Once ice disappears from there, oil level will go down. Correct, people? Now ice has disappeared. Now ice was taking up this volume of oil. Now ice, once it melts, it disappears and it has to go down. So oil level should go down by what volume, people? Oil level should go down by V1 volume. V1 volume. Oil level should go down by V1 volume. And the other thing, V2 volume has increased. V2 volume has increased. So V1 is larger than V2. Therefore, increment is less than decreasing. Increment is less than decreasing. Therefore, the new volume of oil will be here. Okay. Did you understand what I just said? This is how. Wait. I'll explain that. This is how the new level is going to be. This is oil. This is water. I'll explain two things. Water level at the bottom, okay, water level at the bottom increases by volume V1 due to water form during the melting of ice. Okay, that's the first point. Second point, people, oil level will go down. As ice disappears inside oil after melting. Disappears inside oil after melting by volume V1. Wait, this should be V2 now. V2, sorry, V2, sorry, V2, no, not V1, V2. Yeah, V2. It should be V2. Sorry. Because once ice melts, the volume is not V1 anymore. It will be V2, right? That level will increase here, and all the volume of ice now will be taken up by oil. Now this part of oil was occupied by ice before it was molten. Now once all the ice is melted, oil level will go down by the original value of ice, that is V1. So oil will try to go up by a volume of V2, but it has gone down by a volume of V1. Then ultimately it will it would have gone down by what resultant volume of how much? V1 minus V2. V1 minus V2. V1 minus V2. Okay, right. I'll just write that statement and finish it off. Therefore, finally, okay, so since volume increased is less than volume reduced, oil level at the top will go down eventually, Okay, that's enough. What's the answer then, people? Considering all these things, what should be the answer? Water level and oil both rise up. Water level rises up, oil level rises down. I think that's the answer, no, people? Second one looks more, second one looks fine. I'll go with second one. Okay, and I think I have explained it here enough. That's it. I think you don't have to get fixated on this. Just one more quick revision and finish it off. People, ice is going to melt and it's going to turn to water. But the problem is when ice melts and turns into water, the volume doesn't remain the same. The volume reduces. You have to know that. Because density of volume is less, density of ice is less than density of water. Therefore, its volume will be greater because their masses are equal. So when ice melts, you will get more water into the system. Water is denser than oil, so water level will definitely go up. Now oil level will go down. You know why? Ice is melted, so there is no one here. Then this oil will go down to fill up this space. So the volume of oil going down is V1. The volume of water increased is V2. Therefore, oil will also try to go up by height of V2, but V1 is bigger than V2. So ultimately, oil will also go down. That's what happens in this question, right? That's enough. Sixth one. So this is that question which is slightly difficult to figure out. So if you get confused here, you should leave this and go to the sixth one immediately, people. That's the kind of question this is. Okay, should not get fixated on this. Just move on. What is the acceleration of the M2 in the given figure? The plane and the pulley are smooth, and the string and pulleys are light. So right, fine. Okay, people. What should we do? Mark all the forces quickly. What are the forces we have? There will be M2G here. There will be M2G, the weight of the object, M2G. There will be, tension acting here. T. Same tension will be acting everywhere. No, here T. Oh no, T. Also T. And since the pulley is light, remember it's a light pulley, so it should have the same force acting downwards as well. That is 2T. Upward force is 2T, downward force 2T. So on this object there will be a 2T mass. Right. So when you leave the system like this, people, obviously this is going to accelerate downwards. No, this is going to accelerate downwards, and this is going to accelerate horizontally. But there is a small issue. Can you tell me the acceleration of this object? Can we put it as A, people? I don't think we can put it as A. It should be 2A. It should be 2A. Because when this moves x distance, this will move only x by 2 distance. Do you get my point? Do you get my point? When M1 moves x distance, here x by 2, here x by 2. Both sides x by 2 will only go down. Therefore, M2 can't move x distance because it's like that x distance move will be distributed x by 2 on either side of the pulley. Because when you move x distance, if x distance is moved here, then x distance should move on the right side also. Totally 2x distance is moving, which doesn't make sense. Therefore, you should know. I'll write it here. When N1 moves x distance moved by distance x, M2 will move by distance x by 2. Therefore, if the acceleration, this is, I think they are asking for the acceleration of A, right? What is the acceleration of the acceleration of M2? What is the acceleration of M2? So I have taken that as A. If I take this as A, it should be 2A. Okay, how did I get the A and 2A here? Because people, you can apply this equation, S equal ut plus half at squared for both the objects. If you put half at squared, u is 0 for both the objects, and so it's x equal at squared by 2. S equals 0 plus at squared by 2. T is common for both the mass. T is T is common for both the mass. Common for M1 and M2, because if M1 moves 1 second, M2 is also going to move 1 second. Therefore, this is proportional to acceleration. Remember, so if the displacement of this is x, and if the displacement of this is x by 2, then acceleration should be that way. Okay, right. In the final paper, we have never come across questions like this, where we have to consider accelerations in different way. So highly unlikely that you will get questions like this in a final paper. But anyways, if you get a question, you have to be reasonable. Then what do? You apply the equation separately for both of them. First of all, let's apply for M1 horizontal, because it's moving horizontally, F equal ma. So horizontal force, there's only one horizontal force acting, that is T equals M1 into 2A. Okay, right. And then for M2, we have to apply the equation vertically downwards, F equal ma. Vertically downwards, M2G minus 2T equals M2 into A. Okay, so if I continue, M2G minus 2T, instead of 2T I have to substitute this one. Now see, T is equal to 2M1A. 2T means 2 into 2M1A equal to M2A. People, we are supposed to find out A, therefore M2G is going to be equal to M2A plus 4M1A. Then M2G is equal to, you can take A out, inside bracket you will be getting M2 plus 4M1, and final answer, A equals M2G over M2 plus 4M1. Is there an answer like that, people? First answer, right? Here, M2G over 4M1 plus M2. So you have to go with first answer. So if S is proportional to A, then the object which moved with have A by 2 acceleration. Yeah, somehow I have taken this as A by 2. එතකොට මේකට A කියලා දාන්න ඕනේ. If this is A by 2, this is A. I have taken this as A because they are asking us to find the acceleration of M2. No? So if you take this as A, this is A by 2. If I take this as A, this is 2A. Doesn't matter. It's just the multiple. No? This is twice this. So I can put any number I want. Correct? Any number I want in there. If since they are asking to find the acceleration of M2, I am taking that as A. If not, I'll be confused. Because if I find A, then I have my final answer. No? So whatever you are supposed to find, take it as A or X or whatever the letter you introduce. The other quantities can be with respect to that. That way it's easier. That way it's less risky. Okay, right. So that is the most important part. This part I've done here. That's the most important part in this question, because you have to get that. If you put A and A here, people, I think you would have gotten a different answer. So anyone who got the first answer for this question, hurry up, please. Anyone? Oh, good. Aisha has got the answer. Right. But so if you couldn't get the answer, it's okay. Let's learn something from this. Right. Let's move on to the next question. That is question number 7. Question number 7. Okay, this one. Right. Question number 7 and 8. Let's see what it is all about. Question number 7. Hold on. As shown in the figure, a chain of length capital L. Okay, chain of length capital L. This is a past paper question, people. Chain of length capital L is kept on a smooth horizontal table and released. If the motion starts at t equal to 0, the graph which shows the variation between velocity of and time until chain touches the ground. Wow. Okay. So it is a smooth table. That's important. So there's no friction, right? There's no friction. Then we have to find the velocity. Now people, we can compare this to a situation like this. You can compare this to two objects connected like this. Okay, I think you can compare it this way, and now everything is smooth now. So you can consider there is a, let's say this is m1, this is m1 and this is m2 kilogram. So this is going to go for this way and this is going to go this way. Now under normal circumstances, this is how it's going to happen, where there will be weight m2g and here tension and the same tension acting here and all those things. So what I'm trying to do here is I'm going to get an equation for A is acceleration, and then this based on the variation of that, let's decide how velocity is going to change. But the interesting part, it's with time m2 is going to increase, m1 is going to reduce. Do you understand that? Because there are three loops. Now once it falls a little, 4 loops are down, 5 loops are up, 5 loops are down, 4 loops are up, 6 loops are down, 3 loops are up, 7 loops are down, 2 loops are up, 8 loops are down, 1 loop up. Likewise m2 keeps increasing, m1 keeps reducing. Did you get that point? So raise your hands. Okay, so when right, so okay, so compare this part. What I'm done is, wait, I'll explain this part of the chain. I have taken it as m2 mass. This part of the chain I have taken it as m1 mass. So I'm put this is something we can understand with the diagram I have drawn on the right side. And in between the loops there will be tension. Because of that tension only loops come down together. So now let's analyze that quickly, and we know what to do. For m1 you can apply the equation horizontally, f equal ma. That means T equals m1a. Remember there is no tension, there is no friction. So I apply the equation for m2 downwards, f equal ma. That is going to be m2g minus t equal to m2a. Both will be moving at the same acceleration for sure. Now instead of t you can put m1, m2g minus m1a equal to m2a. So m2g equals m1a plus m2a. Therefore people, still m2g is equal to m1 plus m2a. Final answer, a is equal to m2g divided by m1 plus m2. We are getting an equation like this for a. M2, right. With time, what will happen to m2 and m1? With time m2 increases and m1 decreases. Okay, right. So tell me, how will you decide the variation of a with time? For that, up and down, let's divide by m2. So m2g over m2 here, down m1 plus m2 over m2, and that will give me an equation for a, that is g on top, constant, down it will be m1 over m2 plus 1. Sorry, right, okay. So now what will happen to this is the final equation for acceleration, people. What is happening to m1 and m2 with time? M2 increases, okay, m1 decreases. Please tell me what will happen to a with time. What will happen to a with time? So with time a increases or decreases? This value will decrease with time. So denominator will decrease with time. Therefore a will increase. With time a increases. Okay, with time a increases because of that equation. I mean, it's easy to understand, people, here. M1 is going to reduce, M2 is going to increase, means this value is going to reduce with time. Numerator is reducing, denominator is increasing, so this whole value will reduce with time. So here we can say, so M1 over M2 reduces with time. If the denominator is reducing with time, A will accelerate, sorry, A will increase with time. A increases. If A is increasing with time, people, what is the answer? What is the answer? If A increases with time, what's going to be the answer? Height is greater than L until it touches the ground. No, until it touches the ground. Then should be the fourth answer, I think. No? What do you think, people? Shouldn't it be the fourth answer? No. This will happen only once the chain leaves the table. Once it leaves the table, it will fall under gravity, right? It will fall under gravity. Correct? It will fall under gravity because once the chain leaves the table completely, M1 will become 0. When M1 becomes 0, A will be equal to G, and after that it will fall under constant gravity. Therefore, I think the answer must be the fourth one, people. This is correct only until the chain is on the table. Do you get my point? Once the chain has left the table, it will fall under gravity now. As shown in the figure, length of chain L is greater than. What do you think? Why not 3? 3 is wrong somehow. 3, it is decreasing acceleration, this graph. No, initial part is decreasing acceleration. If the acceleration is increasing, for that the VT graph should look like this. Increasing acceleration graph, increasing gradient, this way. So the correct answer for this question is, even the fourth one, I'm not very happy. The correct answer for this question should be like this. The initial part should be a curve followed by a perfect straight line. Curve followed by perfect straight line. This is until this point, chain is on the table. Chain is on the table. And this part of the graph, chain falls freely. Chain falls freely under gravity. So even the fourth one is not very satisfying, but out of the answers given, I think that's the best choice we have here. Gravity. Okay, and why is the first part like that? Because it is increasing acceleration graph. Increasing acceleration. Okay. So how H is greater than L? I think Maria, I think there's a problem with the diagram. H should be this. Probably H is this. Yeah, there's a printing error there. I think H should be this, the height to the table from the ground. Yeah, so Maria is asking, how is this possible? H can't be greater than L. H should be the height from the ground to the table, I think. Right, so I think we can settle with the fourth answer. Let's go with the fourth answer. Yeah, H should be they should have mentioned about, now it's like this. We should know whether the chain is hitting the ground while some part of the chain is on the table. I think H must be this definitely, because that height of H doesn't make any sense. No? So please change this if you have taken a printout of the paper. Right, that's it. It's a good question, people. It's a very good question. It's basic concept, but you have to think in a different way. Right, fine. Eighth one. A capacitor of the capacitance C is connected to a battery and charged to a potential V. After removing the battery connection, earth the capacitor, and after that the distance between the plates reduced to half. Then the new capacitance and new potential of it will be. So they are grounding the capacitor. Now that's something we might have to be bothered about, but will it be a problem for us? Will it be a problem for us, people? Because when you ground it, potential becomes 0. No, right? I think it should be fine. What else should it be? Let's try to focus on it in a normal way. So first they are connecting a capacitor to a battery. First they are connecting a capacitor to a battery and they are charging it. So once that capacitor is fully charged, this is V now. Across the capacitor there will be voltage V and capacitance C. And then they are separating the capacitor, people. Then they are separating the capacitor. Okay, wait. Okay, never mind. So then they are separating the capacitor and capacitor. I'll draw it bigger now, a little bigger. And then in that capacitor, we will have a potential of V, and it will have a capacitance of C. It will have a charge of Q. Okay, right. And the gap between the plates is D. What will happen if we ground the capacitor? Now there will be one plate will be positively charged and one plate will be negatively charged. So when you ground the capacitor, which plate is grounded? Okay, right, never mind. Then let's see what will happen if you do it this way. Normally, let's continue. When you reduce the distance between the plates by half, who will change, people? Who will change? Who will change? Obviously, two things will definitely change. Who are they? Now this is d by 2. Who can't change? Tell me who can't change. Charge cannot change. Charge will remain constant. So same charge Q. Potential will be different now. I'll take it as V dash, and the capacitance is also going to be different, C dash. Charge will not change. Why is charge not going to change, people? Why is charge not going to change? Anyone can say the reason for that? Charge will, these are past paper questions. Charge on capacitor will not change. Charge on capacitor will not change since charges cannot flow anywhere. Charges cannot flow anywhere as the capacitor is disconnected. As the capacitor is disconnected from the circuit. As the capacitor is disconnected from the circuit. Good. Right, now let's write the equations one by one. People, tell me the equation for QCV. We all know Q equal to CV. The problem is we need to know what happens to a capacitor when we earth it, no, people. Otherwise, we won't be able to decide that. No, we can. Wait. No problem. Sorry. Q equal to CV, people. Tell me an equation for C. C is equal to A epsilon naught over D. Sorry, A epsilon naught over D. A epsilon naught over D. Yeah, done. Shape. And then the other one, this is the equation for C. What is C dash now? C dash is going to be equal to A epsilon naught over D by 2. That is 2A epsilon naught over D, and that is equal to 2C. All right. Then let's go write the equation, the other equation. This is the first equation, and then the other equation we can write is Q equal to C dash V dash. C dash V dash. So Q, instead of Q, I can plug this one CV, but Q is equal to CV. But Q is equal to CV. So Q is CV. C dash is 2C into V dash. How do I know C dash is 2C? Using the capacitance equation. Therefore, the C will get cancelled out now. Here, C will get cancelled out. Then V dash, I'm getting V by 2. V dash is equal to V by 2. So that's the answer I'm getting for that. 2C and V by 2. Is there an answer? I'm getting fifth one, people. Anyone else who got the fifth one? Fifth one, no? This is a past paper question, so let's go. Should not be a big difficulty. If you have done the past papers properly, you should have got this answer. Electric field. Correct. So when you reduce the gap between the capacitance, the capacitance will double, and I don't see any other answers here. So let's go ahead with this. Capacitance definitely has to be doubled. So the other answers are not correct. 1 and 4 are definitely wrong. Capacity has to be doubled because capacitance doesn't depend on charge or voltage. Yeah, that is also fine. Yeah, that's also fine, Amna. Yeah, that the way you thought also correct. Good. So Amna is asking, Q is constant, people. Q is constant. Q is equal to CV. Here, Q is equal to C dash V dash. In all these answers, this is the only answer which gives a multiplication of C and V as CV. Fifth one, because when you multiply these two, it's 2CV, 2CV, 4CV, CV by 2. But this is the only one which is giving CV. Yeah, Ahmad Karanda Gulon. Right, good. So we are done with 8 questions, and let's move on to the next one. Ninth one. The above figure shows an optical fiber with a core of root 3 refractive index and coating with 1.5 refractive index, which air kept on, which is kept on air. The incident angle on optical fiber to have a total internal reflection at A. Right, okay. So I think this diagram is also not very satisfying. Let's focus on the cross section of the diagram. Okay, people, so this is the cross section, and I'll go this way. Right. Perhaps we can make it even bigger. Oh, what, you know what? Wait, let's not worry about the bottom part. Just focus only on the top part. Let's make it draw it generously and bigger. So this is one only top part I'm worrying about. So what are the refractive indices here? N of AI is 1. This is core, and this is the coating. Core has a refractive index of root 3. Yeah, so this N1 is equal to root 3. N2 is equal to, for my convenience, I will put it as 3 by 2. Half means 3 by 2, na, people? 1.5 means 3 over 2, na? Okay, right. So if you want total internal reflection to happen, this should happen. Wait, so it's refracting like this, and it should strike at least at what angle? Let's find out what angle is that. We call it the critical angle, no? We call it the critical angle. So first let's find out the critical angle and see how we can proceed. Okay, this is our critical angle, C. This is 90. People tell me, if this is C, what is this angle? If this is C, this is 90 minus C. Agreed? 90 minus C, and they are talking about this angle of incident, that is I. They are talking about angle of incidence. So I'm going to get rid of the original diagram, people. Let's forget about the original diagram for the time being. Okay, this is I. This is letter I. Looks like some simple Q. It should be I. Right. So let's first of all consider this. There are two scenarios, two interfaces, 1 and interface 2. So I'll focus on interface 1 and apply Snell's law. N1 sine I1 equal N2 sine I2. So what is N1? Root 3 sine C equals, the other side is 3 over 2 into sine 90, because this is refractive, critical angle. Then people, sine 90 is 1, that is root 3 sine C equal 3 by 2 into 1. So sine C will be equal to what? 3 over 2 root 3, which is again root 3 over 2. Alright, so what is sine C, people? So you can say now sine C is equal to sine 60, because root 3 by 2 is sine 60, no? That means our C has to be 60. C has to be 60. If C is 60, then what is 90 minus C? So 90 minus C is equal to 30. 30, right? Okay. So 30 should be 30. And then if it is 30, let me apply the equation for interface number 2. N1 sin I1 equal N2 sin I2. Okay, right, listen now. N1 is AR, so 1 into sin I. N2 is this core root 3 into sin I2 is sin 30, because 90 minus C is 30 now, people. 90 minus C is 30. We have figured it out. So tell me, what is sin 30? Sin I is equal to root 3 into half, that is root 3 by 2. So once again, sin I is also equal to sin 60. Wow. So I is equal to 60, people. I is equal to 60. What I have considered here is for critical refraction. I have written for critical refraction. For critical refraction. For critical refraction. Right. That's a doubt. Yep, good. So we have found all these numbers now. But the problem is, the question is total internal reflection happening at this point, no? This point. Is this A, people? I didn't see that in the previous diagram. Is it A here? Anyone? Yeah, perfect. Yeah. A. If for critical refraction to happen, what is the condition? Tell you. For the critical refraction to happen, what is the condition? For critical refraction to happen at A, for critical, no, not critical refraction, critical not critical refraction, sorry people, for total internal reflection, no? For total internal reflection to happen at A, for total internal reflection to happen at A, what is the condition? Angle of incidence at A should be greater than C. Means angle of incidence at A should be greater than, what is C? 60. So when this is 60, this is also 60. So when this is 60, this is less than 30. This is less than 30. This should be less than 60. Should be less than, between 30 and 60. Why they have put 30 and 60? Is it okay if it is less than 60? No, wait. No, when C, this angle is greater than 60. This angle is less than 30. When this angle is less than 30, this angle is going to become less than 60. So as long as this is less than 60, it's fine, no, people? When this is less than 60, this is less than 30, because I can write an equation. Yeah, because now when this is 30, this is 60, and this is 30, with this is 60. Okay, so if you want this angle to become less than 30, then you want this angle to become less than 60. So yeah, 90 minus C should be less than 30. That means I has to be less than 60. Because look at the equation here. Look at the equation. N1 and N2 are constants, people. So if sine one angle reduces, the other angle should also reduce. Answer is fourth. Right. I think it would be better if you can get an understanding like this, people. Right. I'll draw the diagram again. I'll draw the diagram again with different values now. Wait. So the question is this now, people. Now they are saying there's a ray like this, and the ray goes like this, and this has to happen. So let's take the angles now. Our concern is this angle. Now I'll take this angle as I for the time being. Let's take these two angles to be I2. I2. I take this angle to be I2. That means this angle is also I2 and this angle is I1. Okay. So we'll compare with the diagram. I think then it will be easy for you can understand it better, I believe. So if you want total internal reflection to happen at A, what is the condition, people? I2 should be greater than 60. What about I1 then? I1 must be less than 30. Good. If this is greater than 60, that means when this becomes 70, this becomes 20 now, people. I1 is less than 30. And so I must be less than 60. Because why? How did I write this way? How did I write this way? Because when I1 equal to 30, I was equal to 60. And we know an equation to connect between I and I1, that is N1, right? So here 1 into sine I was equal to what is that, root 3 into sine I1. So what I'm trying to tell you is, when I1 reduces, I also has to reduce. So if I want I1 to be less than 30, I has to be less than 60. And this is also not a new question to you. There are so many such questions we have done, past papers, model papers, so not new. So let's find these numbers and then make a comparison. All right, fine. So that's the answer for 9th one, people. The last one. The following figure shows a graph drawn in an experiment done by, I think, parallax method, to find the situation of images formed by convex lenses. The power of the lens will be. Now some of you are asking me, two of you messaged me and asked, sir, what is the value here? What is the value here? Really? Anyone? What is this value? Did anyone figure it out? What is going to be this value, which is not given in the question? What is this value? That is also 0.02. That is also 0.02. That is also 0.02, because that's when, how do I put it? Like when you draw a graph of 1 over V, okay, 1 over V and 1 over U, remember. So, 1 over V minus 1 over U equals 1 over F. Right, convex lens. Then convex lens, no, people. So for convex lens, what about F? F is negative. So 1 over V minus 1 over U equal to 1 over minus F. So if I make that the subject, 1 over V equals 1 over U minus 1 over F. Is it, or should it be the other one? Or else have they gone with only the real images? Have they mentioned anything like that? No, of images. Parallax method. In parallax method, right? Fine. Minus, and V is also minus, no, people, for convex lens. You keep the object here and you get the image here. So we know V is minus, U is plus. So 1 over minus V minus 1 over U equal to 1 over F minus F, sorry. Therefore, if you rearrange this equation, you will end up in an equation like this. What is that equation? 1 over V equal to minus 1 over U plus 1 over F. So here the equation looks similar to y equals minus mx plus c. So what is m? Gradient is equal to minus 1. Gradient is equal to minus 1. If this value is 0.02, this value is 0.02. Understood? This value is 0.02. Okay. So I think it was Najla and some. How did you both understand that? I told you, you have to figure it out. Because the gradient is minus 1. If the gradient is minus 1, whatever the value you put here, it will be here also. If in other words, this angle will be 45. This angle is 45. This angle is also 45. So it is a isosceles triangle. So these two sides should be equal. So people, the intercept of the graph is 1 over f. So 1, okay, hold on. 1 over f is equal to 0.02 per centimeter. So f is equal to 1 over 0.02 per centimeter. That is equal to 100 over 2 centimeter. So f is equal to 50 centimeter. 50 centimeter. Okay, right. And we know power of lens has an equation. Power of lens. What is the equation, people? Power of lens is minus 1 over f. It is minus 1 over. You have to substitute this in what meters? 0.5 meters. So it's minus 0.5 meters. Why did I get minus as the value, people? Because for convex lens it's negative, the lens sign convention. Therefore the final answer is going to be plus 2d, because minus and minus gets cancelled out. 1 over 0.1 is 2. Answer is 3. Amon, if you got third answer, please. All right, good. So I see a few hands going up. Now you have to be mindful about, you need to know two things. One is the equation which governs this graph, number one, and then you need to know that when you find out the power, you need to substitute for focal length in meters, right? Unless you consider that, I think you will be in trouble. No, you would have gotten second answer if you haven't converted it to meters. Done. Okay, so with that we are done with 10 MCQs. Can I know how many you guys managed to get right, people? What do you think its value would be? Out of 10, first 10. You can work it out, man. Okay, so that's a 6. Yes, Naya, what do you think its value would be? The value of 10. Okay, let's continue. 11, 12, 13. Okay, 11, 12, 13. I think 12 we will need some extra space probably, so I will we'll focus on 11, and 11 will take some additional space on top. 12 this one. Okay, right. So one is 10,000 column. What is the other column? Consider the following statements about an following expressions on optical instruments or something like that. So translation is not very pristine, but it's okay. Hope you can understand what they're trying to say. Yes. So I'm going to give you another. Okay. The angular magnification of a combined microscope. I think it should be compound microscope. No, people. It should be compound microscope. No. Let's change it. Compound microscope. So we are going some couple of questions try out. So as you know, is not dependent. It does not depend on the position of the object. What do you say about that? That is wrong. That is wrong, people. I'll tell you why it's wrong. Now, if you take statement A for compound microscope, okay, for compound microscope, what is the equation for angular magnification, people? Angular magnification is given by VO over FO minus 1 D over FE plus 1. Okay, so there VO is image distance for object lens, which depends on what? Which depends on the position of the object. Because if you change the position of the object, people, the image distance will change. Because image distance depends only on object distance. Therefore, A is wrong. So they are asking for the accurate statement. That means the correct statement only. So answers with A are wrong. 3 is wrong. 5 is wrong. The image formed does not belong to normal adjustment condition if combined microscope is virtual and upright. That is correct, no, people. That is correct. Does not belong to normal adjustment. Because in normal adjustment, what kind of image do you get? Because in normal adjustment, final image is what? Tell me. Inverted and virtual, not upright and virtual. So B is correct. If B is angular magnification from a telescope in normal adjustment conditions, have to use an eyepiece lens with higher diameter. That is wrong. For a telescope, people, capital M is equal to FO over FE. FO over FE. So a telescope will look like this. In fact, a telescope will look like this. You might have seen. It has to look like this. Diameter of FO will be bigger, whereas diameter of FE will be smaller. You know why? If then only this can happen. I'll draw something and show you. Then only this can happen. I mean, they will get diverged to their focal point and then they will go out like this. If FO is bigger than FE, this is what's going to happen. These are past paper questions. There are so many past paper questions which help us compare the diameters. Okay, so this is FO. This is FE. Correct? So FO is bigger than FE. Alright? So FO has to be, so for M to be high, FO should be bigger than FE. So when you talk about diameter of FO must be bigger than FE, but they are saying the other way around, no? Eye lens with higher diameter, wrong. It should be object lens which should have the higher diameter. Therefore the answer is only B, first one, only B. So then aren't they mentioning image formed at infinity? No, even image formed at infinity is still going to be virtual, right? Virtual, no? It can't be upright, no? Image formed at infinity, is it upright? It's inverted. Image formed at infinity will be inverted. Final image. Wait, yep. Image formed at infinity, Maria, it's a virtual image. No? Okay. So it's also inverted. Final image is inverted. Okay, well, we'll try there. So I think I really have to. No, this is what they're saying, Maria. They are saying if the image formed is virtual and upright, it can't be normal adjustment. Yeah, no. Okay. Right. Is there lag in my voice, people? Is there lag? I really love how you remembered to put the comma there. Awesome. A little, but manageable. Amna, how about now? Is it still lagging? And what about the others? Come on, please give me a response quickly. Okay, now it's fine. Right. For 12th one. A real image. A lot of spelling errors and printing errors are probably due to translation. A real image of magnification of 4 is formed 20 centimeter distance from a convex lens. Real image. So let's draw that quickly. Magnification 4. Magnification 4. That means definitely this is what's happening. The object should have been between f and 2f, because when you keep it beyond f to f, the image will be diminished. So object should be here, then only you'll get a real image, and then they are getting an image somewhere beyond 2f, and that image is going to have a magnification of 4. 4. Okay, 4. So if I take this as u1, let's say u1, and this one is v1. What's the relationship between v1 v1 and u1, people? If you take this height as h, the height of the image is 4h, and we know v1 over u1 is equal to 4. That is the meaning of linear magnification. And v1 is in fact given to us. No, v1, the value of v1 is given to us, so we can mark it. v1 is equal to 20. v1 is equal to 20. Image is formed at 20 centimeter from convex lens. What is the distance of the object which should be placed from the lens to obtain a virtual image with the same magnitude? Virtual image with the same magnitude. Maybe they are talking about the same size, is it? Fine. So people, let's try to figure out the what this thing now. V1, we know V1 is 20, so 20 over U is equal to U1 is equal to 4. That means U1 is equal to 20 over 4, that is 5 centimeters. 5 centimeters. That is the initial object distance. Now, what is the distance of the object which should be placed from the lens to obtain virtual image with same magnitude? Wow. Right. So go to Mehimagam, right? I think this is what they're talking about. When they say magnitude, what are they talking about? Saying what do they mean by magnitude? So I have few concerns there. Wait, using these numbers, people, we can find out the focal length. People, 1 over v minus 1 over u equal to 1 over f if you substitute. 1 over v is 1 over minus 20 minus 1 over u. 1 over 5, no? 1 over 5 equal to 1 over f. So LCM is minus 20. Here on top minus 1, here minus 4. Correct, people? Yeah, that is equal to 1 over f. So 1 over f is equal to minus, wait, something is wrong. No, the minus 1 come at the bottom. Minus 1 come at the bottom. So it is 1 over f. What is 1 over f, people? Minus 1 over 5. Because this is minus 1 over 4. This is minus 5 over 20, that's minus 1 over 4. The f is equal to 4 centimeter. We have a convex lens of 4 centimeter focal length. We have a convex length of 4 centimeter focal length. How many of you figured this out? Raise your hands if you found out that f is equal to 4. That is pretty straightforward, no, people. Right, now let's move on to the next category. They are asking us for the same magnitude. So that is a bit of a concern for me. I mean, what are they saying? Are they talking about same magnitude means? What is the distance of the object which should be placed to obtain a virtual image with the same magnitude? To people, then there's a problem. A real image of magnification 4 is formed 20 centimeter distance from a convex lens. This is 20 and this is 5. So it should be placed inside f, then the answers must be less than 5, no, people. Confusing, this part question. What is the distance of the object which should be placed from the lens to obtain a virtual image with the same magnitude? The virtual image means you have to keep the object inside f, no? Don't know whether this 20 was the object distance then initially. Then this, according to these answers, then this 20 has to be object distance, then 80 has to be the image distance, then minus 8 20 16 here. I think that should be the that is how it should have been, no? A real image of magnification is formed from 20 centimeter distance from a convex lens. That's how you have, I think that is how it should have been. So with these numbers, I think we will not be able to get a proper answer. Sorry. And I think they are asking for the same magnifications. If you want the same magnification of 4, then we'll have to place the object. And if you want the image to be virtual, then you have to place the object inside f. So our answer must be less than 4. There is no answer less than 4. Okay, why don't we do this, people? Why don't we do this? Shall we do it this way? Wait. Now I'll give you some time and tell me if you can figure out the answer. So I have to change some numbers here. Right, I will erase all these things. Very well tried. I'm going to give you another sticker. Excellent, perfect sticker over here. Okay. So let's get rid of this. I'm going to make a real image of magnification 4 is formed. So let me just some dots over formed. So now can you tell me the number which is represented when object is at object is at 20 centimeter distance from a convex lens. Okay, what is the distance of the object which should be placed from the lens to obtain virtual image with same magnification? Let's put it that way. All right, Naya. So before we move ahead, okay, please take a couple of minutes and do this question and send me the answer. The answer is correct as well. Let's say that you're feeling in your class, now, find it challenging, find this question challenging. I'll give you like a couple of minutes for you to try. Alright, so I have one response. Okay, that's from Najla. What about the others? Since our time is running on, people, I'll do the question quickly. Yeah? So according to question now, the numbers have changed. This number has to be, this is unknown now. This becomes unknown. And U1 is 20. U1 is 20. I made that change in the question. Without that change, I don't think we can complete this question. So let's make this 20. If U1 is 20 people, V1 has to be V1 has to be 80. So V1 over 20 is equal to 4, and that makes V1 equal to 80 centimeters. So 1 over V, it's negative V1 is 80 now. So 1 over minus 80 minus 1 over 20 equal to 1 over F. 80 can be taken as LCM, minus 1 minus 4, right? Minus 4 equal to 1 over F. So that is 1 over F equal to minus 1 over 16. So F is equal to minus 16 centimeters. Minus 16 centimeters. Minus 16 centimeter. Okay, that is the focal length. So you have, if you want a virtual image, you have to definitely place the object where? Inside F. Inside F. So the object is placed here. We don't know what that object distance is, and the image will be formed somewhere here, and we want the same magnification. Therefore, the V is going to be 4U. Did you get it? Then only we will be getting the same image, same magnification, people. Then now we'll apply the equation. 1 over V minus 1 over U equals 1 over F. 1 over V is 1 over 4U minus 1 over U equals 1 over F is minus 16. On the left side, let's make 4U the subject, 4U the common denominator. 1 minus 4 equal to 1 over minus 16. So this 4 and 16 can be cancelled out. 4 and 16 can be cancelled out, so it should be minus 4 at the bottom here. Minus 4. So what is the final answer, people? I'm getting minus 3 over U is equal to 1 over minus 4, and the final answer is 12 centimeter. Yeah, so we got the answer. 12 centimeter. 5,040. Right, so that makes sense. That makes sense. And we are getting the that answer is also given. So I think this should have been the question. This should have been the actual question with the changes. Right. I hope you learned something new here. This is somewhat similar to a support seminar question, people. There was a question like this in a support seminar as well. Quick. Okay, done. Then we'll move on to the next one. 13, right? Question number 13. Okay. A person with short distance eye defect has 20 centimeter far point and 20 centimeter near point. When he wears a pair of spectacles to clearly see the distant object, his near point will be. Okay. A person with short distance eye defect has a 200 centimeter far point and 20 centimeter near point. When he wears spectacles to clearly see the distant objects, that means okay, he should be able to see objects at infinity. His near point. Nice. This is a very interesting question. Now let's see what this is going to be. Look, let me put a diagram quickly. Okay. So I'm going to put a few diagrams here. 1, 2. Let's put 3 diagrams. Okay. So I'm going to place the object in front of his naked eye and see whether he's going to see or not. This person. All right. First, the object is at infinity. Let's say object at infinity. What will happen? If the object is at infinity, the person can't see it. Cannot see. Why? His far point is just 200 centimeters. So he cannot see it. So cannot see clearly. If you just see the object as a blurry image, there's no point. You should be able to see it clearly. On the other hand, when you place the object at 200 centimeter, what happens, people? He can see it. 200 centimeter, he can see it because that is his far point. Okay, I'm going to work out this question for you, right? So can see. So here they're asking us to figure out the missing part. Where else can he see, people? Add these together, you're going to get 6,000. Where else can he see? When he places the object at 20 centimeter, also he can see. So whatever is at 20 centimeter, he'll be able to see. Whatever is at 200 centimeter, he will be able to see. Whatever is between 20 and 200 also, this person will be able to see. Okay, right. So then I'm going to write now, what are they doing? When he wear a pair of spectacles to clearly see the distant object. To see distant objects, a lens must be worn. A lens must be worn to create an object kept at infinity. Where? Kept at infinity. Oh, sorry. I will read it again. To see distant objects, he can't directly see the distant object. So when he wears a lens, what that lens should do is it should create an image of this object at infinity at his far point. So to see distant object, a lens must be worn to create an image. You can't create an object. No, we will create an image. Sorry. Create an image. We want. Wait. A lens must be worn to create an image of object kept at infinity. Image of object kept at infinity meters. Okay. So when you keep the object here, that lens should create an image here. So he will be able to see that image. No? Therefore, let's draw that remedy. What lens is he going to wear? We can figure out the lens he is going to wear. So he's going to wear a lens. Lens. So our object at infinity, remember, object at infinity. Infinity makes u infinity, infinitely large, and we are getting an image, and that is at 200 centimeters. Then only he will be able to see it, no people? Right. That's what happens when someone wears a lens. That person is not directly seeing the object. That person rather sees the image. So if you apply 1 over v minus 1 over u equal to 1 over f, 1 over v is 1 over 200 minus 1 over infinity, 1 over infinity equal to 1 over f. So that is 1 over 200 minus 0 equal to 1 over f. That means what is f, people? F is equal to plus 200 centimeters. So it's a concave lens of 200 centimeters. Concave lens. Now the question is, people, what is his near point? Right. Now he's wearing the lens. Okay. He's wearing the lens. Remember, this person is wearing the lens. If I keep the object at, the person is wearing the lens. What lens is that? Concave lens. If I keep the object at 20 centimeter, will that person be able to see the object? He's wearing the lens, remember. Now this person has kept the object at 20 centimeters. Tell me, will he be able to see it? 20 centimeters. Will he be able to see it? Yes or no? Yes or no? No, he can't see it. He can't see it. Okay. He can't see it. Okay. He can't see it. Right. Somehow, what is your question? Short-sighted ones use convex lens. This person is short-sighted and far-sighted somehow. This person is not short-sighted. This person is far-sighted. Wait, short-sighted. I'm getting confused now. The person wants to see distant object. When the person wants to see distant object, this is what we have to do, no? Mayhem, I don't by heart it. You can do it this way. You can analyze it like this, no? When you keep the object at infinity, that person can't see. But when the object is at 200 centimeter, the person can see. So when I keep the object at infinity, I need an image to be created closer to me. Which lens will create an image closer? Concave lens will only create an image closer. Okay, and short-sighted people, what do they wear? They wear concave lens, right? Concave. Yeah, that's it. Short-sighted person should wear concave lens, not convex lens. These are small things. Careful. So my question was, will this person be able to see this object? He can't. You know why? Concave lens always creates an image closer to the object. So this image created is within 20 centimeters. So cannot see. Cannot see. But if he is not wearing the lens, he can see. He can see the object at 20 here. So the best option is, if you want to read something, he doesn't have to wear this lens, because he wants to wear this lens to see objects at infinity. Now his new what near point, it's going to be this. We have to get the image at 20 centimeter. Remember, the image must be formed at 20 centimeter. You need to get an image at 20 centimeter. Okay, so object must be definitely placed away from 20 centimeter, because he is wearing the lens, remember. So when he wears the lens, the minimum distance he can afford for the image distance is 20 centimeter, because if the image is formed inside 20 centimeter, he can't still see it. So this distance is what we have to find out. And the focal length here is 200. Now, f is equal to plus 200 centimeters. Now people who have done theory under me, I have explained all these things, A to Z, exactly same thing. Maybe I might have explained with 25 and 200 or something like that. Only the numbers are changed. Right, if you put 1 over v minus 1 over u equal to 1 over f, 1 over v is 20. This is our v image, v. 1 over v is 1 over 20, 1 over u we don't know, 1 over 200. Right. This one, I'm getting 1 over u equal to 1 over 20 minus 1 over 200. 1 over u equal to 200, here becomes 10 minus 1, I'm getting 9 over 200. Therefore, people, what is u? U is equal to 200 over 9. Anyone who divided this and got the answer? Was it 22.22 or something? 22.22 centimeter. I'm getting first. Anyone else who got the first answer? I'm getting the first answer, people. Right. So the purpose of this lens is to see distant object. So if you want to see near objects, don't use this lens. That's the idea behind this. There are so many such past paper questions, model paper questions. You should have definitely done this in your theory. Go through the theory and try to revise it again, because when the person doesn't wear lens only, he will be able to see the object at 20. When he wears the lens, if you keep the object at 20, that lens will create an image inside 20 centimeters, so he can't see that. Okay, so you have to play, while wearing the lens, you have to place the object such that the image is created at 20 centimeters, so that you will be slightly higher than 20. Okay, right, done. So when he, okay, let's write a final point. What do you call that? Range of vision when wearing lens. Tell me now. Range of vision when lenses are not worn. Lenses are not worn. Lenses are not worn. Tell me, what is that? What is the range of that person's vision? That is 20 centimeter to 200 centimeter. 20 centimeter to 200 centimeter. He can see only between 20 to 200. Okay. Okay. Well, right. Wait. I didn't read the question. I didn't read the answers. Wait. I'm now come back to the answers. And now range of vision when lenses are worn. What about the new range of vision, people? New range of vision is going to be 22.22 centimeter to where? Infinity. Which is not bad at all. Just 2 centimeters, right? Fine. And people read the answers. I'm sorry, there's the answers saying displaced 22.22 centimeters from the eye. So earlier it was 20, now it has gone to 22.2. So what is the answer? Should be the second one, no, people? Should be the second one, right? Should be the second one, I think. Should displace. Displace means the near point has moved by what distance? So it was earlier it was 20. Here 20 is the near point. This is our near point. This is the far point. And here new far point and new near point. So the new neo point has gone 2.22 centimeters away from the eye. I think that's what these answers mean, right? Displaced 22.22 distance from the eye. No, that means the new distance, according to first statement, the new distance becomes 42.22. No. Yeah, displaced from the eye means away from the. I mean, from the eye, where how much it went? The cowl the 102. I mean, from the eye, it has gone 22.22 centimeters. Sorry, 2.22 centimeters away from the eye. Either way, people, final answer is 22.22. I sense a small translation issue here. So you get the point, right? 22.22 centimeter is the new near point. 22.22 centimeter is the new near point. So you have to choose between first and second. Earlier it was 20, now it is 20. So what do you think is the answer? But how many of you chose the first answer? How many chose the first answer, people? Okay. How many of you chose the second answer? Okay, right. So it's a bit of a conundrum, no? So I will give marks for 1 and 2 both, but make sure you read the answers properly in the final paper. It becomes 22.22 or it increases by 22.22, something like that. So you have to read the statement carefully. Here it's not that clear what they're trying to say. I also, my gut feeling says second one is what they are trying to mention. But I'll give answer 1 and 2 because if you have got that 22.22, that means you have done it right. Only the last part is wrong. So in the final paper, let's read it properly and decide. Okay, right, fine. We'll not get fixated. We'll move on. But all of you should have got 22.22. Not it's not good enough. You should have done it because that's quite a regular question under ID effects. Now, question number 14, isn't it? Question number 14. What is this about? I think a question from Heat. Am I lagging, people? I'm lagging, or is it manageable? 14. Is there a lag or manageable? Some yes means is there a lag or manageable? For which question is it yes? Slight lag but manageable, no? Okay. Right. Okay. Question number 14. Shown below is a cooling curve which is drawn using a mass of melted paraffin and allowed it to cool naturally. Allow it to cool naturally. So the temperature reduces, then becomes constant, and then reduces. So people, we know obviously here it should have been liquid, and here also it should have been liquid, and here it is freezing. No? It is freezing. So liquid is turning into solid here. Okay. After constructing suitable tangents to the cooling curve, the cooling rates QA, QB were obtained at the positions which paraffin start to melt at A, and the positions the paraffin finished melting at is B. Okay, so here and here they have drawn tangents to get those. Right, here and here they have drawn tangents to get what cooling rates QA and QB. Wow, QA and QB. So here they are saying it's QA here, and here the cooling rate is QB. Cooling rate. If the specific heat capacity of liquid paraffin is Ca and the solid paraffin is Cb, so here it is for this part of the graph you have to use Ca. For this part of the graph, you have to use CB. The latent heat of fusion of paraffin will be okay. Then people, how did you do it? Why, when they say cool, after constructing suitable tangents to the cooling curve, cooling rates QA and QB were obtained at the positions which the paraffin started to melt A. So for liquid paraffin, I'll try to write an equation. Q equal MC delta T, right? So dQ by dt, that is equal to MCA. Instead of delta theta, what can I delta? Okay, that will be, sorry, MC d theta over dt. All right. Then yeah, I think this is how we have to do. So dq by dt we do not know. I'll just put it that way. And here it is MCA, people. d theta by dt is only given as QA. Right? First equation. And for solid paraffin, let's write another one. For solid paraffin, if you write the equation, because look at the answers, you have QA, QB and all, but are they in the answer? No? For solid paraffin, you write the equation Q equal MC delta T, that's a common equation. We have to introduce rates, so we have to divide this by time, and again MC d theta by dt. dq by dt the same, because the rate of cooling will remain same. Rate at which heat energy is lost to the environment will remain same, equal to at this point and this point, because at this point and this point temperature is same, no people. Temperature is same. We all know dq by dt according to Newton's cooling law. Newton's cooling law, proportional to theta minus theta r. Remember people, theta is constant for point A and B. Therefore dq by dt will be constant as long as temperature of the object and room don't change. That's why I'm using the same dq by dt. This time it is M CB QB. Second equation. Okay, right. I have one equation, I have two equations. Then if I add 1 and 2, what do I get? If I add 1 and 2, on the left side I will be getting 2 dq by dt, and on the right side I will be getting MCAQA plus MCB QB. Therefore dq by dt has a new equation. What is that? That is why I think M, you can take it out and divide by 2. Inside the bracket you have CAQA plus CBQB. Do you see an answer like that? I see that here. See, probably this is the answer then. Then people, for melting, what can you do for this part? What is the equation I should be writing for this part? Hurry up. What equation should I be writing for this part? That is going to be Q equal MLF. So dq by dt is equal to MLF over time taken. dq by dt, we have an equation, that is m over 2 into CAQA plus CBQB equal to MLF. Instead of time taken, you have to put this time, no people, this time. This is that T I have marked. So what is that T, people? Anyone? You have to put T2 minus T1. So M and M are gone. What is the final answer, people? I think the final answer is similar to the third one, right? Third one. I'm getting the third answer. Okay, if you have any problems, we can have a discussion, people. LF for me is equal to CAQA plus CBQB T2 minus T1 over 2. Right, I'm getting third. If you have got any other answers, let's have a discussion. If you have any doubts to be clarified. Oh, it's a cool question. Don't know whether you didn't figure out that Q and QB are temperature, rate of change of temperature. What happened? What are the answers you people got then for this question? Tell me, people. This is also somewhat similar to past paper questions. I can remember the exact diagram in 2007 or 2008, I think, before 2010. No answer. So if you did not get an answer, just tell me if you didn't get an answer. If you got any other answer, just tell me what answer you got. Okay, Aisha has not been able to figure out what is Q and QB. Aisha, did you understand now? Because dq by dt can't be different. It has to be same for point A and point B and the freezing process, because the object's temperature and temperature of room are not changing from A to B. Therefore, dq by dt should be same for every process. I thought QA and QB was dq by dt, right? Amari also has thought the same thing. Right, fine. But I hope this gave you some clarification. But then let's move on. Then 15th one. 15th one. Relative humidity question of paper. Relative humidity. 15th and 16th. Let's focus now. What's the time? 7:53. Time. This time consumption is a little too much, right? Okay, let's quickly go with 15 and 16. Only the water vapors are included in a closed container. The relative humidity of it is capital H. Now its volume is reduced up to half, so one fourth by keeping the temperature constant. Then the relative humidity of the container is H2. I think this one is H1. No? This one has to be H1. Because the H1 or H2 they asking. If the vapors in the container is unsaturated condition throughout the time, the ratio H1 or H2. So they have not got saturated. Oh yeah, it's a simple question. What are the answers you got, people? Share your answers. Earlier it was volume was V. Now the volume is V by 4, I think. No, 1/4. Volume is reduced to 1/4. So Amna Suddin has got the first answer. So okay, 1/4. Right, Aisha also got the first answer. Let me quickly go through this. People, whenever we do questions regarding humidity, we have to consider a few things. Now volume here we'll take it as V. So volume here is V by 4. Okay. Mass of water vapor. Mass of water vapor. It's equal to M. Please tell me the mass of water vapor here. What is the mass of water vapor? Waiting. Mass of water vapor will be M. Very good. It will be M because it is still unsaturated, right? So no dew is formed. Therefore, mass of water vapor cannot change. Mass of water vapor cannot change. This is unsaturated. This is also unsaturated. Then I'll underline that part and say, if the vapors in the container is in unsaturated condition throughout the time, right, fine. So you can say, so mass of water vapor doesn't change. Then, right, that's it. So RH here is RH is equal to H1. No? RH is relative humidity. RH is equal to H1. Here RH is equal to H2. Tell me something else which is constant here. They have told the temperature is constant. People, temperature T. Temperature T. Here also same. I think it was mentioned there, constant temperature here. So here also temperature T. If temperature is constant, someone else will be constant. What is it? Absolute humidity of saturated vapor remains constant if the temperature doesn't change. Right, let's finish this off, people. RH, what is RH? Equation for RH. RH is equal to absolute humidity over absolute humidity of saturated vapor multiplied by 100. Remember, the one we put at the bottom depends only on temperature. It doesn't change as long as temperature doesn't change. So first equation, H1 will be equal to, what is absolute humidity? Mass over volume over this one, absolute humidity of saturated vapor into 100. And H2 only changes the volume. Oh, we have to be a little careful now. divided by, I'll put 0.25 V, because 104 V, no people, over absolute humidity saturated into 100. Fine. Then when you divide them, H1 over H2, what will happen? Tell me. 100 and 100 will get cancelled out. Absolute humidity, saturated vapor cancels out. MOV gets cancelled out. I'm getting 1 over 1 by 0.25. Answer is 104. Simple. Okay. In other words, when you reduce the volume by 4, absolute humidity will increase by 4. If absolute humidity increases by 4, relative humidity will also increase by 4. So the answer is definitely the first one. Answer is first one. Okay, I'll repeat. Mass of water vapor is not changing. It's m na people. Absolute. What is the equation for absolute humidity? Absolute humidity is equal to m over v. Mass of water vapor divided by volume. So if mass is constant, if volume is reduced by 4 times, absolute humidity. Here's the equation for relative humidity. Absolute humidity at saturated vapor is constant, 100 is constant. So if absolute humidity becomes 4 times larger, RH will also become 4 times larger. So compared to H1, H2 will be 4 times larger. Right? Fine. So how many of you got first answer? I think Amna and Aisha, they have got first. Maria also has got first. Maria first or first, right? Good. Right. And I hope others understood this explanation. Let's move on to the 16th question. The surface area of the foot of an people, can you hear me? Is there a lag? Hello? Because I don't get, I'm not getting response from everyone. I'm communicating with Maria, Amna, and Aisha. That's all. Okay, Hamda is there. How about the others? Okay, Asa is there. Where are the others? Right, okay, let's continue then. 16th one. The surface area of the foot of an animal standing on ice is 0.05 meters squared, and its foot maintaining a good heat contact with ice at 0 degrees Celsius. The blood vessels of the foot are at 2 millimeter above the ice. The temperature of the blood is at 35 degrees Celsius steady value, and heat conductivity of the foot is 6 into 10 power minus 3. Wow, easy. It should be very easy. What is the answer, everyone? They have given you the numbers and they are asking you to just substitute and get the answer. dq by dt is equal to ka delta theta over d. K is given 6 into 10 to the power minus 3 into area is given as 0.005 meters squared. So we can directly put that because it's in SI unit. Temperature difference is 35 minus 0 divided by the thickness is 2 millimeter. There you have to be careful. It should be 2 into 10 to the power minus 3. Therefore, 10 to the power minus 3 is gone, 10 to the power minus 3 is gone. This 2 and this 6 are gone, that's 3. So the final answer we are going to get is 3 into 35 into 0.005. So it's like 0.015 into 35. What is the final answer, people? Fifth answer, no? Right, perfect. Fifth answer. 0.525. Hurry up. Good. Okay, now how is the audibility, people? Just change my connection. How is audibility now? Better? Yeah, okay. Thank you. Let's move on to the next question now. Question number 17. Question number 17, they are talking about melting point and all those things. Consider the following statements given about the change of melting point and boiling point of a substance due to external pressure. So, of a substance, they are not specifically told whether it's water. There are two types of substance, people. Substance like wax, substance like water. Okay. Right. Because now they both behave in two different ways. That's the concern I have here. Hold on. Consider the following statements given about, okay, the melting point slightly increases when the pressure is increasing in volume decreasing liquids is while converting solid state to liquid state. Okay. So let me give you a summary here. If you take water, okay, if you take water, people, water, if you take water, we know ice, when it melts, it becomes water. All right. Now, volume, we compared this earlier as well. Let's take the volume of this as V1. Let's take the volume of this as V2. Tell me who is larger, V1 or V2? We discussed that earlier. V1 is larger. V1 is larger than V2. Okay. And on the other hand, we can compare wax. Now you have solid wax. Solid wax. And when wax melts, it will become liquid wax. Here, what do you think about, what do you say about volume, people? What happens for the volume? Now we'll say here volume is V3, and here we'll take the volume is V4. Here it's the other way around. V4 is bigger. V4 is bigger. Okay, opposite, exactly. Yeah. You can try this at home. Nowadays you must be using candles and everything. You can try this. Try to put wax somewhere and then melt it and see what happens to the volume. Try to fill something with try to fill a certain try to fill a small vessel, or small, if you can find a metal lid, put wax to a certain point and melt it and see what happens to the volume once it has completely turned to liquid. Volume will increase. Now we all know for water, we draw a graph like this. For water, people, what is the graph? We draw a graph like this, a phase diagram for water, people. So phase diagram goes like this now for water. This is pressure and this is temperature. Okay, this is for water. Hope you can remember this. Now you have, what is this region, guys? This region is low temperature, high pressure region, solid. This region is high temperature, low pressure region. This is gas, and this region is liquid. So this is the line which helps us compare the melting points. Now look, I'll put two pressures. For this pressure, this is the melting point, and for this pressure, this is the melting point. There are another, so P1, P2. Here we have T1, T2. T1, T2. Got it? So T1, what is T1? Describe T1. Melting point at pressure P1. T2, melting point at pressure P2. But you see, P1 is smaller than P2, no, people? P1 is smaller than P2, and T1 is greater than T2. T1 is greater than T2. See, T1 in x-axis, T1 is larger than T2. In y-axis, P2 is only larger than P1. So what can I say? So when pressure is increased, what is happening to melting point of water, people? When pressure is increased, melting point reduces for water. Melting point reduces for water. What do you think will happen to wax then? For wax, what do you think will happen? For wax, it's the opposite of this. When pressure is increased, when pressure is increased, what will happen, people? When pressure is increased, melting point increases. This is a comparison between wax and water. So I've done a whole new lesson for you. Now let's read this statement again. The melting point is slightly increased when pressure is increased in volume decrease in liquids while converting solid state to liquid state. So when they say volume decreasing liquid while converting the solid state to liquid state, means they are talking about a liquid like who? Liquids like who, people? Hurry up. Volume is decreasing during melting, that is water. Water, right? Water, not wax. Water. So now tell me, is that statement correct? The melting point is slightly increased when pressure is increased. That is wrong, the people. When you increase the pressure, melting point reduces. Wrong. A is wrong. Why? Because melting point of water reduces when pressure is increased. Reduces when pressure is increased. That's what I was explaining all this time. So if statement A is wrong, which answers are wrong? Oh goodness me, all correct. They're asking for the correct statement. So a lot of statements are wrong. Second is also wrong. It's either third or fifth. B part, people. The melting point is slightly increased when pressure is increased. When melting point is slightly increased when pressure is increased in volume increase in liquid while converting solid to liquid state. Do you agree with B, people? B, statement B. Melting point is slightly increased when pressure is increased in volume increasing liquid. They are talking about what liquid here? They're talking about who here, people? They're talking about wax, no? Volume increasing liquids while converting solid state to liquid state means they are talking about liquids like wax. Example, wax. Is that correct? For wax, when pressure is increased, melting point increases. Yes, that's correct. That is correct. Okay. I thought a B correct means, people, there's only one answer. No? There's only one answer. The boiling point is slightly increased when external pressure is increased in any liquid. Now for water, we can say that, no problem. For water, look at this. Now, boiling means you have to go here. There's a temperature here, people, T3. But for any liquid, can we say that? That's the concern I have. This is T4. This is T4, okay? So can someone describe what is T3 and T4? T3 in the diagram, okay? T3 is boiling point. Boiling point at P1 pressure. At pressure P1. T4, all right? Boiling point at pressure P2. So obviously P1 is smaller than P2 and T3 it's smaller than T4. So with increasing pressure, what happens? With increasing pressure, boiling point increases. With increasing pressure, boiling point increases. So that statement is correct for water, people. I'm not sure whether it's true for wax, but according to the answers, definitely there's no other option but third one. So I think looks like the boiling point part is also same for wax as well. Put the cake check karunga. Just let's check it. Maybe we can just Google it and see what happens to melting point of wax when you increase the pressure. Not melting point, boiling point. Okay, but I hope you guys understood it. Here is a summary of comparison between liquids and their melting points. 18th one. This you must have learnt under heat. when you learn about melting, fusion, vaporization, all those things. The radius of Earth is r and the gravitational acceleration of the surface of Earth is simple g. That means yeah, when you read that you can write down something, no people. The radius of Earth is capital R, the gravitational acceleration on the surface of Earth is simple g. We can write an equation for simple g. What is that? Simple g is equal to, tell me the equation. Let's see who can remember. If you can't remember the equation, dead, no people. Simple g is equal to what? Hurry up, hurry up, hurry up. Simple g is equal to the, yes, gm over r square. Gm over capital R square. You have to remember that. Gm over capital R square. Increasing of the gravitational potential energy when bringing an object of mass m from an external point at r distance from surface of Earth to external point at 2r distance from surface of Earth will be. This is also a past paper question. You must have done this in your theory classes and yeah, in term test papers. Quite familiar question. Should be a quite familiar question. So let's wrap it up. Okay, until I prepare the screen, people, tell me the answers. What are the answers you guys got? Hold on, check the answers. So I have one response. Let's see. Maria got the fourth one. Amna Sudin has got the first one. Aisha also has got the first one. Good. What about the others? I'm not sure which one is correct. Najla also has got first. Hamdo, who is also has got first. So only one person has got fourth answer, which is interesting. Now they are taking the object from this point to this point again. I'll take this as point A. I'll take this as point B, because they are saying r distance from the surface of Earth. First point is r distance from the surface of Earth. The second point is 2r distance from the surface of Earth. Oops, sorry. To r. So this is also r. Remember, this is also r. And people, change in gravitational potential energy is what we are supposed to find out. Now, how do we do that? Now, change in gravitational potential energy. I think we might have to use gm. Now this will give you gm equal to gr square, because in the final answer you don't see capital G and capital M, right? So change in potential energy is, people, which point will have higher potential energy, A or B? Can someone tell me which point will have higher potential energy, A or B? A or B? Which point will have higher potential energy? Hurry up. People, the point with higher potential energy will be B. No. B. Come on now. Potential energy, gravitational potential energy is negative, na people. Gravitational potential energy at infinity is 0. 0 is a larger number than all the negative values. When you go away from Earth, gravitational potential energy increases. Remember that. Because negative values, no. So you have to put it this way. Gravitational potential energy at B minus gravitational potential energy at A. What is the equation for gravitational potential energy at B? Minus gmm over 3r. You have to put from the center. Minus gmm over 2r. All right. So this is how it has to work. And I'm getting this minus and minus will get multiplied, so becomes plus gmm over 2r minus gmm over 3r. So if I continue it here, gm simple m over r can be taken out. Inside the bracket I have 1 over 2 minus 1 over 3. What is 1 over 2 minus 1 over 3, people? There is 1 over 6, right? So I'm getting GMM over 6R. But we all know GM is equal to simple GR square, correct? So if I continue it here, change in gravitational potential energy, people, will be equal to what? Gr squared M over 6R. The final answer is mgr by 6. So the correct answer for this question is first one. Maria, what happened? I think you have forgotten to take the distance, the radius, no? So they are clearly saying, even though the translation for some of the other questions were horrible, this one okay, shape. They are clearly mentioned from the surface. So that one. Done. Right, then 19th and 20th. 20th one, people, let's see, 20th one. We taught you, no? So 19th one. What is 19th all about? X and Y are two objects floating on a liquid. 1/4 of volume of X is at the above the liquid. X is above the liquid level, and 2/3 of volume of Y is immersed in the liquid. Ratio of densities X and Y. Okay, interesting. Okay, so fifth answer. One person has got fifth answer. What about the others? Anyone else would like to share your answers, people? Right, majority has got fifth. So let me quickly finish this off. What is the question about? X and Y, two objects floating, 1/4. So we'll draw both together. X 1/4 of X is above the liquid level, like this, and Y, 2/3 of volume is immersed in the liquid. 2/3 of volume is immersed in the liquid for Y. So this is how X and Y are going to look like. So this is our X, this is our Y. So we have 3 over 4V is submerged. 3 over 4V is submerged here, and 3V over 4 is submerged, and here directly 2V over 3 is submerged. 2V over 3 is submerged. Then it's a matter of just writing the equations and getting the answer. So what's the plan, people? The liquid densities, right? So for X, if I write the equation for X, we know upthrust has to be equal to mg. Have they given the masses of the objects, people? Are they equal in mass? How did you take their masses equal? No need, right? So for upthrust, you have to put the submerged volume, that is 3V over 4 into density of the liquid, that is rho, floating in a liquid. So density of density of liquid, rho L, G equal to mass of the object will be volume times density of X, G. Okay, density of X. So you can see G and G are going to get cancelled out. V and V are going to get cancelled out. No, therefore you will be getting a first equation for rho X. We have an equation for rho X. Density of X is equal to 3 rho L by 4. I think this is very simple. We'll quickly finish it off. Then if I apply the equation for Y, again density, upthrust is equal to 8. For upthrust, we have to put 2V by 3, that is submerged volume, into density of the liquid into G, equal to, for mass, you have to put total volume, density of the object into G. So once again, we can get rid of G and we can get rid of V. So now I'm getting an equation for density of Y, that is equal to 2 rho L over 3. So we have to find out rho X over rho Y now, people. What is rho X over rho Y then? Rho X over rho Y is equal to 3 over 4 divided by 2 over 3. So that is 9 by 8. 9 by 8. Fifth answer, very simple. Fifth answer, good job. Right, then the 20th one. It's a pitot tube, I think. This is a tube which is not pitot tube. Yeah, pitot tube. Non-viscous incompressible fluid with density rho is flowing through a tube with velocity v. P1 and P2 are the pressures at A and B respectively. Consider the following statements. The fluid flowing velocity V is proportional to something like this. VA is greater than VB, PA is greater than PB. People tell me what is the velocity here? At point A, what is the velocity? At point A, we can take the velocity as V because AI is flowing. What is the velocity at point B, people? It is taken as 0. It is 0 because it stopped. It is stopped by this part of the tube. Okay, right. And according to Bernoulli's theorem, we know here there will be a pressure PA, here there will be a pressure PB. What is the equation we can write for these two people? The equation I can write is according to Bernoulli's theorem. According to Bernoulli's theorem, PA plus half rho VA squared equal to PB plus half rho VB squared. That's the normal equation we write now, people. So we can say PA plus half rho V squared equal to PB plus 0. Alright. Now tell me who is larger, PA or PB? Who is larger? Is it PA or PB? Obviously it should be PB, right? Because with PA, when you add something only, you are getting PB. Good. So, and the other thing, if I make V the subject, forgot that point, rho V squared by 2 is equal to PB minus PA. V squared is equal to 2 to PB minus PA over rho. That means V, that is V squared, I said. V is equal to square root of 2. Have they given PA and PB? P1 and P2, no? That is PB is P2 minus P1 over rho. So we can definitely say V is proportional to P2 minus P1. Why? Rho and 2 are constants, no, people. That means statement 1 is correct. Statement 1 is correct. VA is V, VB is 0, that is also correct. But PA is smaller. Then this is wrong. People, A, B correct. I am getting 4th answer. Anyone else who got the 4th answer? I'm getting 4th. You must have done this in your Bernoulli's theorem theory part. Yes. 4th. That's all. What about the others? Why? If you have any problems, please just tell me. What's the issue? Why did you get 4th? And if you have any doubts, you can ask me. So I got it this way. Can't we do it that way? So why have you written this? People can ask questions. Right? Fine. So that's the end of 20 questions. Good. So for 20 questions, we have taken nearly 2 hours and 30 minutes, which is horrendous, but can't help people. Right. Okay. Now what are we going to do? Are we going to continue, or do you want to take a break? We have done nearly for 2.5 hours exactly, maybe 2 hours and 15 minutes. We have done 20 questions so far. What shall we do? What's the plan? Shall we continue, or do you want a small break? Small break would be better, no? Because you're staring at that. Even I'm staring at the screen now for a long time. 10 minutes? 10 minutes? Till what time can we continue? Till what time can we continue? I don't think we definitely can't finish all 50. That's how MCQs work. We can't do 50 MCQs in one day. It's literally impossible. 9:30. Okay, we'll go till 9:30. So let's temporarily stop the session now, and let's resume at 8:40, sharp 8:40. So if you want to eat something, you can eat something, right? I have to prepare for tomorrow's class. I have to put the link and everything we will for tomorrow's class, so I need to do that right now. If not, it will be too late.